In this next section, we're going to talk about a very important compound that's important for both chemistry and also biology, water. Notice how water is situated. It is made up of 2 hydrogen atoms and 1 oxygen atom. So 2 different elements coming together to create this complicated molecule called water. Now, we call water a polar covalent molecule because it is the polar covalent bonds that are holding the hydrogens to the oxygen to create the compound. When we say polar covalent, remember we're talking that there is an unequal sharing of electrons. There's 2 hydrogens versus 1 oxygen. So here's a better picture that shows us the polar covalent bonds that hold the 2 hydrogens to the oxygen to make water. So because of the number of electrons that hydrogen has, hydrogen normally has a slight positive charge, as you can see from the diagram. This sign here that looks like a figure 8, that's the Greek symbol for charge. Okay, so there's nothing really to worry about that. We normally don't use it, but in this particular diagram they did. So hydrogen has a slight positive charge because of the number of electrons. Oxygen has a slight negative charge, again because of its number of electrons. So when you put the 2 hydrogens and the 1 oxygen together, notice you've got 2 positive charges to just 1 negative. That's what they mean by unequal sharing. 2 positives and only 1 negative. It's not equal. Okay, so now that you know how water is created using the polar covalent bonds between the 2 hydrogens and the oxygen, we're going to talk about properties that only the water molecule has, beginning with a special type of chemical bond. It's called the hydrogen bonds. Only water can form a hydrogen bond. Okay, and this is not the same thing as the ionic bond or the covalent bond. Only water can form hydrogen bonds, and you know that because when you look at water, you do not see each individual water molecule. You see one fluid substance. So 2 water molecules join together because of that special hydrogen bond. The hydrogen atom, the positive side of one water molecule, is attracted to the oxygen, or the negative side, of another water molecule. So here's a quick diagram to show how the hydrogen bonds form between the 2 water molecules. And this is why you see one fluid substance rather than each individual water molecule. Now, because water can form multiple hydrogen bonds, it has a very special property called cohesion. Cohesion means when 2 of the same substances are able to stick together. So water can stick to water. So it has to be 2 of the same substances sticking together, and that's called cohesion. Because the water sticks to itself, it has another property called surface tension. Surface tension is like a thin film at the top of a glass filled with water. And you can break the surface tension or you can leave it intact. And the reason why you know that you have broken the surface tension is if you place an object at the top of the glass and it sinks, the surface tension has broken and it has allowed the object to sink. If the object floats, the surface tension stays intact. Now, what if you have 2 different substances sticking together? That's called adhesion. It's like a sticker sticking to your shirt, or tape sticking to a piece of paper. 2 different substances sticking together. So water can stick to other things. Water can stick to glass. Water can stick to paper. Water can stick to clothing. So anytime water sticks to something different, it's called adhesion. So, for example, water sticking to glass. And you know that water sticks to glass if you see this little curve at the top, what we scientists call the meniscus. Then there's a special instance when adhesion and cohesion are working together. Whenever that happens, when adhesion and cohesion work together, that's called capillary action. And the perfect example of capillary action is when you drink by a straw. So whenever you're drinking water by a straw, the water has to travel together. So the water molecules are sticking together. You're not sucking up each individual water molecule. It's still one fluid substance. So the water molecules are being held together, water sticks to water, same substance, by cohesion. But the water also sticks to the inside of the straw. So water sticking to something different, so water sticking to the straw is adhesion. So again, in order to have capillary action, you need to have both cohesion and adhesion. Now, water has the ability to decompose. When it decomposes or breaks down, it forms two types of ions, a positive ion and a negative ion. The positive ion is called hydrogen ion. The negative ion is called the hydroxide ion, and there are the abbreviations in parentheses. Hydrogen ions are abbreviated H+. Hydroxide ions are abbreviated OH-. Now, sometimes we like to measure the concentration or the amount of hydrogen ions in a particular substance. And in order to measure the concentration of H+ ions, we use what's known as the pH scale. So the pH scale ranges from 0 to 14. Pure water is always neutral at 7. Anything that's neutral has an equal amount of H+ ions and hydroxide ions. So H+ equals OH-. Acids are below 7 on the scale. That means that there are more hydrogen ions, more H+ ions. The stronger the acid, the lower the number. So 1 or even 0 are the strongest acids. Bases, on the other hand, are above 7. That means that bases have more hydroxide ions or OH- ions. The strongest base is going to be 14. Okay, so here's a pH scale and where some common substances that you may know of fall on the pH scale. So battery acid would fall in between a 1 and 2, so it's strongly acidic. Then you've got fruit juice and vinegar, shampoo. Notice how pure water is always neutral. Alkaline is another name for base. So notice that tap water is a very weak base. Milk of magnesia, which is like Pepto-Bismol. And then drain cleaner and paint stripper are very basic.